Wait, oh, just kidding. Never mind.
Okay. Now, this is a very common type of problem like that that shows up in homework, on tests, standardized tests. There's always something about this type of problem that bothers me, though. And that is the characters in the problem are slightly dumb. So, even more so than most ones. Okay. Tickets for a play.
Do you want to rise? Whoa.
Yeah, write this one down. Tickets for a play are $3 for, let me double check this, $3 for students and $5 for non-students. Tickets for a play are $3 for students and $5 for non-students. Okay? On opening night, 937 tickets are sold, and this number's odd as I recall.
It's a pretty big theater.
Apparently. $3,943 are collected. $3,943 are collected. With just this information, how many tickets were sold to students? This is a very common type of problem, and you set them all up the same. It can be a little hard to recognize which is which. But
you can do this over both.
I'm sorry?
You can do like a portion.
Oh no, not quite. No, that's not a proportion problem. Good guess though. It looks kind of like one. Here's the problem with it though. Why couldn't they have frickin' made the tickets different colors? Or written student or non-student on them? Or just counted, or put them in different bins or something?
That's dumb.
Yeah, apparently there's something that has always bothered me about these. Okay, but here's when you see a problem like this, you've got to turn each of these, you've got to turn this information into two linear equations. Into two linear equations, the answer is going to be where they intersect. Okay? How can we turn this in? Well, first, so it's going to be two linear equations. We need an x and a y. We got to label them first. What are we going to label x? What are we going to label y?
Students are X.
Students and non-students. Students are x.
What's the reason for that, though?
For labeling them?
For labeling X for making X students.
Well, because we're trying to find out how many tickets were sold to students.
Okay.
So that's going to be our variable. It's going to be our unknown. Okay? Now, if x is going to be students, the other thing we have in this problem that is also, that we're trying to count students, the other number we have is how many non-students we had. Okay? So I want to make that y. Y is non-students. Okay? X is students, Y is non-students. You okay? Okay. All right, now, tell me something you know about the students and the non-students, about X and Y.
Cost
$3.
$3 for tickets. Okay, it costs $3 for these guys to show up. Tell me something a little simpler. If you can think of something mathematically a little simpler you can tease out of this. Now, that's the cost. We actually use an X for the number of students, not the cost of the tickets.
You do like
X plus Y equals 937.
That's what I was looking for. Actually, that's the first one.
Really?
The number of students plus the number of non-students had to add up to the number of people there. X and Y is 937.
And then you find 1, right?
Well, we're going to find one, but you can't, if you have two variables in one equation, you can't do anything.
Yeah, you can.
Unfortunately. We need to find another equation. And you guys are on the right track. Here's where the cost is going to come in. You don't have any ideas as to the information I haven't used yet.
Would it be
$3, $5, $3,943.
Would it be 3x plus 5y
Try and
equals
stop
3,043?
Every time I've taught this, it has taken longer than that for someone to say that. Actually, to get that second equation. First one I usually can get pretty quick. Second one usually takes longer than that. Thank you, Sade. Here's your 2 bits of information. Students and non-students together made 937 people.
Okay.
Each of the students gave me $3. So I got to multiply $3 by the number of students. Each of the non-students gave me $5. The $3 from each non-student plus the $5 from each, I'm sorry, the $3 from each student plus the $5 from each non-student gave me a total of $3,943. Yes, Amanda?
You can use something.
Substitution.
We can use substitution or linear combination. Rodney, would you prefer substitution?
Mm-hmm.
Since Rodney suggested that first, I'm X or Y. Which one do you want by itself?
X.
Rodney says X. There's a smart reason to say X.
No. Wait.
How many tickets were sold to student? X is what we're looking for. Okay? So X equals 937 minus Y. Did I correctly get X by itself?
Yes.
Yes. Now,
Are you gonna plug it back in the second equation?
yeah, and actually, Rodney, I gave you props for the wrong reason. Actually, we're going to wind up getting Y by itself. We're going to wind up answering the wrong
So
thing
I was
first.
right.
Oh, boo.
But that's all right. Yes, we should have gone with the other one.
Wait, you
But-
have to get Y by itself?
No, either